This timing cover goes an old Land Rover 4-liter aluminum block V8. It contains the oil pump cover. It's made out of steel. Here's our 3-gear assembly. Comprises the oil pump. These are steel. If we look inside the housing, we can see a bunch of grooves and some deep ones. If we look at the cover, we can see some areas of wear, and we can see a couple of grooves. And if we look at the gears, see if a camera can pick it up, we can see where this has been slightly grooved. And here's our smaller gear. You can see this has been also worn. Now the clearance, acceptable clearance between these gears and the cover, which goes over them, is 1.5 thousandths to 3.5 thousandths. That's adding the clearance on this side and the clearance on this side. So when we see wear marks like this and grooves like this, you really don't need to measure it to know that you're out of spec. Because this vehicle was run low on oil and with very dirty oil. So we're going to fix that. So the first thing we're going to do, we're going to machine this down flat, because this is too much variance for us. We want this to be flat within a 1/10,000th of an inch, what we call a tenth. Then what we'll do, we will machine down this face in here so that it is perfectly flat. And we'll make sure to measure the depth of this cut. This is a factory cut. We'll measure that, and we will restore it after we're done cutting. Then we will take a brand new gear and we will measure the height of the gear from here to here. Then we will machine down this face to make up for any material we've taken off here. So that way we'll insert the new gear, and we will have taken the height of the gear, measured this depth, and taken the difference minus 1.5 thousandths, or 15/10, and that's how much we'll take off of this face. And when we're done, we will have restored this timing cover to full functionality. So I noticed that inside here, the surface finish is not all that great. I've got a surface out here. Yeah, the surface finish isn't necessarily great there either, but I can put this in the lathe and cut about a thou off here so that I get a nice, perfect surface on which to indicate. Because right now with the surface finish in here, I'm getting 5/10 variation. There we go. Nice even surface we can indicate on. Let's get a better focus on that. There we go. Let's take a look at our setup. Zeroed it, and pretty much a 90-degree angle here, so we can keep track of our X and Y. And we're just barely touching it. And what we'll do, we will rotate it using the top of the quill. And watch that dial. And as much as it moves from here to here, we will move our axis half that much. And as much as it moves from here to here, we will move it half that distance on the axis. That should get us pretty well centered. Okay, final setup. We've got a spacer, some parallels. We've got our centering device, a 2/1000 shim, and that 2/1000 shim will spin all the way around. I don't know if I can do this one-handed. I'll mount the camera. So, in order to mill soft metal like aluminum, you need an end mill with wide flutes. This one we would use for steel, but we're going to use this one. That way the chips have ample opportunity to exit the scene. Now that we're level, we got to make sure we're centered. Let's go over here to the DRO, digital readout. There we go. Perfect. So now our spindle is centered on the rotation of the table. We already used our centering tool to make sure that our workpiece was centered on the spindle. So now all three pieces, spindle, the workpiece, and the table, are aligned. So the main cavity where the oil pump gear goes, that's from here to here, that's 3.625 inches wide. Well, the distance, the radius from the center to the edge is 1.8125 inches. Now if we run the spindle over to the edge, then the tool is going to cut into the outer edge and we're going to ruin our part. So we have to take into consideration half the diameter of our tool. Our tool is 0.842 inches, and that means that half the distance is 0.4210. Now we subtract half the distance of our tool from the radius, and that's where the center of our spindle has to be in order for us to mill all the way to the edge, but not into the edge. And this is why we had to be so exact when centering the spindle on the main cavity for the oil pump gear. So here, if we move our spindle from center 1.3915 inches, then we will be right at the edge. As a matter of fact, we'll be at the edge minus 5/10,000ths of an inch. And 5/10,000ths of an inch is close enough to say that we're there, because that is really the limitations of my ability to measure and the ability of my machine to cut. So we're going to go with 5/10,000ths as being right on, and let's get to machining. Now remember, we're going to have 5/10,000ths of a lip here, because that's how close we're getting this to the edge. Or we should say one edge may have 5/10,000ths of an inch lip, but that's going to be okay. So if you look real close, we have a bevel on the gear. Now this is a 45-degree bevel that's 30 thousandths wide. Now what that means is that we have a net clearance of 20 thousandths. It's actually in a few more decimal points, but don't worry about that. About 20 thousandths on our X and our Z axis. So a 5 thousandths wide lip is not going to interfere with the function of the gear. The gear won't even know it's there. So let's move our table over to 1.3915. Right now we're sitting at 0, 0. I'd say that's close enough. So here we are, 1.3925. Actually just a smidgen more. I could get it closer, but it's really splitting hairs. And as I said before, if there's a slight ridge of 5/10,000ths, or even, I mean, it could even be 3 or 4 thousandths, it won't hurt anything because of the bevel of the gear that'll give us 20 thousandths of clearance here. So now we machine it. Well, let's get a good start on finding our 0. 2 thousandths shim here, and place that underneath. I'm going to lower the bit, so gently touching it. Lock that down. Bring us to -2. Right there. Give us a couple thousandths extra here. I'll remove the shim.
First thing we'll do, we'll mark it.
So let's take a close look there. You can see a nice, nice evenly machined surface all the way to the edge of the cavity. I made sure to choose a bit that could do the entire surface in one pass. So our gear height is 0.398 inches. The initial measurement of our depth is 0.414. That means we have a side clearance of 0.016. We want to achieve 15 ten thousandths to 35 ten thousandths side clearance. So we got way too much.
We're going to set our 0 2,000th shim. We're going to trap it there very lightly. We're going to lock down the quip.
Then we're going to set our gauge at 2 thousandths. Move the shim.
So we will be tracking the position of the cutting bit by using a digital readout. So we've calculated all the positions, the turns, and some of these we'll be doing by eye. They're coming around here. I don't have to worry about colliding with the side of anything. If you cut deeply, you'll tend to push the material. You'll warp it a little bit. If we only do 1,000th at a time, then we can make sure that we're getting a nice even cut and that we're not stressing the workpiece so that it throws off our cutting measurement.
Here we are for the final milling. I'm going to take off 2 thousandths of an inch, 1,000th at a time. Then I'm going to put my gear in. I'm going to do a height measurement using a straight edge. Here we go. There's 15 ten thousandths. This is the minimum clearance that I need. No. We have 1,000th of clearance. Looks like I machined the top just a smidgen too much. Oh, look at that. Just barely. Okay, we'll have to correct that. So I double checked my flat edge. It is definitely flat. And we have our, see that, 15 tenths, 0.038 millimeters. This is our minimum spec. See if we can get right underneath there. Oh, that's beautiful. Look at that. Oh yeah, that's exactly what we want to see. Oh yeah. Four thousandths shim. Our maximum clearance is 35 tenths, which is another way of saying 3.5 thousandths. So we should not be able to insert this. That definitely will not go. It is just pushing. Nope. Nope. Alright. We're good. So the way I took 5 ten thousandths off of this surface If you look at one of the previous videos, you'll see how I measured this. Come on, let's get some focus. There we go. How I measured the clearance, and I was off by 5/10 thousandths. The way I milled that down was I took an old, worn-out set of gears and a file, and I made a cross hatch all across the surface. And I soaked it down in WD-40, and I spun it around in there. And that dirt, that black substance, is aluminum. And because we only had to take off 5/10 thousandths of an inch, these scorings did a nice job. And as you saw in the video just previous to this, we're right on the money. So here we have a nice piece of granite, a couple pieces of sandpaper that we have glued. This is the micro finishing area of the shop. And I have been sanding the oil pump cover. At first, going on these rough surfaces. Whew. That's a good 120. This one's right at about 200. This one's sitting at about 400. So one way, rotate at 90, rotate at 90, back and forth. We have a pretty good surface. Here we are in the quality control department of the machine shop. We have a 1,000th shim, and we have our finished product. Our plate should be flat within 1,000th of an inch. Now this is a piece of granite that is perfectly flat. And let's see if we can get our shim underneath more than just the very edge. And it stops there. If you belt sand an object, the very edges become beveled. So you got to make sure that you have enough sealing edge. So this passes muster. I cannot get a 1,000th shim underneath it. So we have our finished timing cover. We have our gears, we have our top plate, and we're going to start off with a couple screws. So we're going to lubricate everything, put it together, see if we have free movement. Nice and free. Here we're going to measure the clearance. We need a minimum clearance of, so it's 15/10 thousandths, or for you metric fellows, 0.038 millimeters. So let's test it here. There we go. Oh yeah. Beautiful. It is a tight fit. That's all right. Oh, that's beautiful. Wanted to make sure that we had not only the proper clearance from the top of this surface over here, as in a previous video, but that the cover was properly machined. With it lubed up in there, it should be free and smooth. And it is both. So I'm going to replace these bolts. The ones that aren't here got damaged during removal. But there we have it, a successful rebuild of the oil pump assembly. I'll be doing some videos on the oil pressure relief valve in here. I already have 2 of those videos for servicing them. So look through the selection of videos if you want to learn some things about the oil pressure relief valve in a Land Rover Discovery with the 4-point-liter distributorless ignition. Bye for now. Like and subscribe, or I'll set this fella loose in your garage.